Let's explore one of mathematics' greatest triumphs, the Poincare conjecture, proven by the reclusive Russian mathematician Grigori Perelman in 2003. The conjecture states every simply connected closed three-manifold is homeomorphic to the three-sphere. Let's break down what this profound statement actually means. First, what does simply connected mean geometrically? Compare two surfaces, a sphere on the left and a torus on the right. The sphere is simply connected, the torus with its hole is not. Now draw a loop on each surface and see what happens. On the sphere, any loop can continuously shrink to a single point. But on the torus, this loop gets stuck around the hole forever. Now let's meet Perelman's powerful tool for attacking this problem. The key breakthrough came from Richard Hamilton's Ricci flow. Here is the beautiful equation governing how geometry evolves over time. The metric tensor G encodes the shape and distances within the space. The Ricci curvature R measures how much space bends at each point, and T represents flow time, driving the geometric evolution forward. Let's see this equation in action visually. We'll keep the equation small as our guide. Ricci flow acts like heat diffusion, smoothing out curvature everywhere. Start with an irregular, lumpy, three-dimensional manifold. Under Ricci flow, the bumps dissolve and the shape becomes perfectly round. But sometimes the flow runs into serious trouble. Perelman's genius was handling singularities through a process called surgery. Consider a dumbbell shape where flow pinches the thin neck. The neck collapses to zero width, creating a singularity that breaks the flow. Perelman's solution: cut out the singularity and cap each side smoothly, then continue the flow on each piece separately. Now let's assemble the complete proof. The proof follows three key strategies. Combining these ideas gives us Perelman's historic proof of the conjecture. Step 1. Applying Ricci flow to smooth out the manifold's geometry. Ricci flow evolves the metric by moving it opposite to curvature, like heat diffusion. We start with an irregular, lumpy shape representing our initial manifold. Under Ricci flow, the geometry evolves over time toward uniformity. The shape smooths into a beautiful round sphere of constant curvature. But the flow doesn't always proceed smoothly. Problems can arise. Step 2. Analyzing singularities where the flow breaks down. Neck pinches develop as curvature diverges to infinity at specific points. Imagine a dumbbell shape forming two bulbous regions connected by a thin neck. The connecting neck grows thinner and thinner as the flow continues. Eventually, the neck pinches to a point, a singularity where curvature explodes. Perelman's brilliant insight was how to handle these singularities. Step 3. Performing surgery to bypass singularities and continue the flow. We cut out the singular regions, cap the openings, and resume Ricci flow. The manifold splits into finitely many pieces after successive surgeries. Remarkably, each resulting piece is topologically a three-sphere. Let's reveal the stunning conclusion of this proof. Here is the final result of Perelman's work. Every simply connected closed three-manifold is homeomorphic to the three-sphere. Grigori Perelman completed this monumental proof in 2003, solving a century-old mystery. Thanks for watching, and see you in the next video.